Hey guys, so in this video I'm going to talk about how to clear fractions from linear equations. So basically, if problems like this make you shudder, I'm going to show you a trick to make these a lot easier. And I think it's easiest to explain this with examples, so we're just going to jump right into this one, and I'm going to walk you through how to do it. So I've got 1/2 x plus 1/5 equals 6/5. So you might be tempted to just kind of work forward with the fractions, but what if I told you that we could actually just get rid of them entirely? So we're going to walk through the steps on how to do this. And this is kind of this has maybe like a slightly simpler example from some of the really crazy ones. So this is a really great one to kind of focus on some of the steps with. So here's what we do. The first thing that we want to do is find the LCD of all fractions. So in this case, all fractions, 1/2, 1/5, 6/5. So taking all of these into account, what would the LCD be? Well, 2 and 5 have nothing in common, so 10 would be the LCD. So that would just be 10. Okay, so after you find the LCD of all your fractions, the next step is to multiply each part of the problem by the LCD. So before I show you this, I actually want to explain a little bit as to why. So a lot of times people just take math as like, oh, it's just a step that I do and I don't know why. But it actually makes sense if you think about it for a second. So in another video, I've talked about what's known as the multiplication principle. And so in this, I have three numbers. We're just going to call them A, B, and C. So here's what the multiplication principle says. If A equals B, then AC equals BC. So what does this actually mean? This means that as long as you multiply both sides by the same thing, you don't change the problem. So in this example, by multiplying every part of the problem by the same thing, we're really just using this principle. This is really what this is trying to get at. Just do everything to the same side, to everything in the problem, and do it on the same side and you'll be good. So let me show you how to set this up. So remember, our LCD was 10, so I'm just going to write it in green over here. Okay, so what I'm going to do is I'm literally going to rewrite the original problem, but notice what I'm doing. I'm just multiplying each part of this problem by 10. And let's see, in the end, this is 6/5 times 10. So I've literally multiplied every part of the left side and every part of the right side by 10. Therefore, that is really what the multiplication principle is getting at. This is a much simpler way to look at this. This is a kind of harder way to look at this, but it's still the same idea, okay? So now that we've maintained the balance in this, there's a trick that's built into this. So one thing to keep in mind, when you multiply this by 10, that 10 is technically over this invisible 1. So there's no, unless you want to call out the denominator of 1, we don't really need it. So by choosing the LCD, this is a really strategic number to multiply by, because here's what I want to point out. Each denominator divides into this LCD. This was not a coincidence. This is why you choose the LCD. So here's the way that you're going to think about this. You're going to say, how many times does 2 go into 10? How many times does 2 go into 10? And you would tell me 5 times. So I'm going to write it right here. And I'm going to write this out as 5 times this. You'll see why in a second. Okay, so this part here, we're just going to pivot for a moment. We've made the cancellation. The goal here is to get rid of this LCD. So pivoting over here, so same thing. 5 goes into 10 how many times? If I cancel these out, 5 goes into 10 twice. Okay, and now for the last one, 5 goes into 10 how many times? That's twice. Still twice. Okay, so I want you just to notice that I also wrote out a little multiplication symbol here, so you'll see why I did this in a moment. So after you've canceled out all of your 10s, now you have to figure out what problem are you left with. And that is really revealed by looking at what you haven't crossed out. So in this case, in this first part right here, notice what I haven't crossed out, all of this. So this is what I want to multiply together. 5 times 1x. What does that give me? That will give me just 5x. Okay, So now let's continue on down the line. So what about moving on to this little cluster here? Here's what's left over. This is what I didn't cross out. So now I've got 2 times 1. That is just 2. And then finally, for this last little cluster here, so now all that's left here is 6 times 2. 6 times 2 is 12. So look at what we're left with. This is the problem that I'm left with, and this is what I can solve instead. To me, this looks a lot more manageable than working with all these fractions. So let me clear some space. And from here, you just solve this as normal. So I need to get the 5x by itself. So first I'll subtract 2 from each side. So I'm left with 5x equals 10. And then I'll divide both sides by 5 to get x equals 2. And that's it. We're done. So this is the technique that I'm kind of going through in this video. Okay, so let's try this again. I want you to try this one with me. If you don't have the guided notes in front of you, you might actually want to pause and write the video down that this is 1/2 x plus 1/5 minus 1/10 x equals 1 plus 3/10 x minus 2/5. So if you do this with me, this will definitely mean a lot more. So the first thing that I want you to do is just pause the video for a moment, look at all of the fractions, and decide what is the LCD. Hit play when you're ready. Okay, so the LCD of all fractions is just 10. So I have other videos where I talk about how to find the LCD, but the only thing I'll say here is, so you've got 2, you've got 5, and then you've got 10, which is 2 times 5, so it's just going to be 10. Okay, so the next thing that you're going to do, you're going to multiply every single part of this problem by 10. Now, believe it or not, this can actually throw people off, so I do want you to pause the video here and set this up, and then hit play when you think you've got it. Don't worry about evaluating it. Okay, so I'm going to go ahead and set this up. So I've got 10 times 1/2 x plus 10 times 1/5 minus 10 times 1/10 x. And so this is kind of the first thing that can throw people off. What do you do with like the minus sign? I always just kind of insert the 10 in between the sign and the fraction. That's what I like to do. And now here's the second thing that throws everybody off. So make sure that you actually wrote this down. So remember, the direction was to multiply every single part of the problem. So it wasn't to multiply every single fraction, it was every single part, which means that you also multiply this one here. So I'm going to take 10 times the 1, right? And then 10 times the 3/10. And then, good thing I'm almost done because I'm running out of room. This is 10 times the 2/5. Okay, so there's the first part. So up next, let's start this part together and then you can kind of finish it off. So we're going to go through piece by piece as to how these cancellations work. So I like to be very intentional when I cancel. So I think 2 goes into 10 how many times? So notice where I actually write out the multiplication. I write it right here so that I can really easily find it. So if I were to go ahead and do this multiplication, I am left with 5 times 1x. So I'm going to go ahead and write that out. This part here will become 5x. Okay, so let's do the next one. So now I've got this whole little cluster here. How many times does 5 go into 10? 5 goes into 10 twice, so I'm going to cancel these out. Again, notice how I set up my multiplication. So you actually want to make it easy for yourself to find it, because if you write it someplace all over the paper, it's just going to be difficult to reread it. So you do want to take a little bit of care with this. So I'm left with 2 times 1. So this part here, this is going to be plus 2. Okay, so now I'm just going to write down the next sign. The next sign is minus. So I'm just going to put the minus here. And so now I've got to work on this little cluster here. So how many times does 10 go into 10? It goes in once. So I'm going to cross this out, and write a 1 here. So now I'm left with 1 times 1x. That's what I'm left with. So this leaves me with 1x. You don't have to write the 1. I just wrote it just because I just said it. Okay, so I did this side. Maybe you want to pause the video here now and finish the other side. Hit play when you're ready. Okay, so here I've got the 10 times the 1, so nothing to cancel out there, right? So that's just 10. Okay, now here with this little part, 10 goes into 10 once, so I'm going to cancel this out. So I'm left with 1 times. So this is 1 times 3x. 1 times 3x is just going to give me 3x. So this is all plus 3x. And then finally, I'm going to write the minus here because that's what comes next in the problem. So now I've got just this last little part here. 5 goes into 10 twice. So I'm going to cancel these out. 5 divides into 10 2 times. So then I'm left with 2 times 2, which is 4. So I'm going to write a 4 here. And, whew, okay, now we are done. So it's much easier to look at this, though, right, than this original problem here. So I know it seems like kind of a lot of work, but once you kind of figure out how to do it, like right now I'm really taking you through the details. But once you kind of get in the rhythm of this, it tends to go much faster for most people. So let's see. From here, I just have to solve as usual. So on the left side, I've got 5 minus 1x. So this is going to leave me with 4x plus 2. And then on this side, I've got the 10 minus the 4. So this is going to leave me with 6 plus 3x. And now it's just a matter of getting rid of the 3x, bringing this over to this side. So 4x minus 3x will just leave me x. And then I can subtract off the 2. And so x just equals 4. So there's my answer. Okay, so if you want to try this one more time, I have one more example like this. And for this one, I'm actually just going to leave you to your own devices to go through the whole thing. Although if you do want to walk through it step by step, I will also do that. But I highly recommend maybe you just pause and try to see how far you can get. If you don't want to see this example, you can just fast forward and I am going to show you another type of problem that is also tricky. So don't bail on the video quite yet. Okay, so starting with this one. So first things first, we've got to find the LCD and then set up multiplying the LCD by everything. So if you want to do this step by step with me, pause the video, do that, and then hit play when you're ready. So in this case, my LCD is 12. So the 2 is kind of captured in this 4. 4 is 2 times 2, and then you've got this 3. So 4 times 3 is 12. Again, if you're not sure why that is, go back and check out some of my LCD videos. That should kind of refresh you. And so now I'm going to go ahead and set this up, this 12 times each part. And remember, you got to multiply that 12 by the 1. That always gets people. You got to practice that and kind of remind yourself of that multiplication principle. Okay, so let's see. Then I've got 12 times 3/4 plus 12 times 2/3, and then this last little part here, 12 times, let's see if I can sneak it in, 1/3 x, barely got it in. Okay, all right, so now if you want, you can pause here, do your cancellations, hit play when you're ready. Okay, so first I'm going to go 2 goes into 12 6 times. So 2 goes into 12 6 times. So now I've got to do 6 times 1x. So this first part here, this is going to leave me with 6x. Then the next part, nothing to cancel here, just doing 12 times 1. So this is going to be plus 12. And then I got to look at this little cluster here. So 4 goes into 12 3 times. So now I'm going to do 3 times 1x. 3 times 1x is just 3x. So this will be 3x. Crossing over to the next side. So now I've got 12 times the 3/4. 4 goes into 12 3 times. 4 goes into 12 3 times. And now I'm left with taking 3 times 3. So that's 9. Okay. Moving on to the next fraction. So now I've got 3 goes into 12 4 times. So first I just think about that. 3 goes into 12 4 times. That leaves me with 4 times 2. 4 times 2 is 8. And then for the last one, so I've got 12 times 1/3. 3 goes into the 12 4 times. So I'm left with 4 times 1x, and that will just give me 4x. So once again, I would much rather solve this problem than this problem. So now I'm just going to forge ahead with the problem. So on the left side, the 6x and the 3x are going to give me 9x plus 12. And then on the right side, I get 17 plus 4x. Okie dokie. So now I'm going to subtract off the 4x. So I get 5x plus 12 equals 17. And then I will subtract off these 12s to get 5x equals 5. And then I can divide both sides by 5 to get x equals 1. So if you didn't get it, make sure that you take a second just to think about why that might have been. If you feel like, like really look at your work and ask yourself if you're getting lost in the work. And this is something where you really want to take your time. It is a very detailed process, okay? So now we're going to change it up slightly, which maybe you are or are not saying woohoo to. So I'm going to show you another example. I'm going to walk you through the whole thing, and then I got 2 more examples again. So maybe watch this one and then decide if you want to watch more examples. So this is actually a little bit surprising for people. I think this works a little counterintuitively. So we start with the same thing. So looking at the fractions that you see, what's the LCD? So the LCD in this case is still 4, but I want to show you how this is a little bit different. So people get a little bit unsure of what to do if there's a fraction in front and then there's a set of parentheses. How many times do you multiply the 4? So the idea of each part, you're really multiplying by each term. And a term is separated by either a plus or minus sign or an equal sign. So in this problem, how many terms are there? This is 1 term, 2, 3. Those are kind of the 3 parts or the 3 terms. So that's the number of times you actually have to multiply by. So let me show you how to set this up now. So I've got 4 times the 3/4. I don't do anything to the parentheses. If you multiply this to the outside here, so think about how the distributive property works. Eventually, this will carry on into the parentheses. If you multiplied this into the parentheses, you would basically be double multiplying, so you don't want to do that. So I'm going to multiply this, and then I'll do it over here. So 4 times 1/2, and then 5 minus 3x, and then 4 times 5 over 4. Okay, so this is really the key part when you do this, and kind of everything else works the same, but like identifying the parts can be a little bit tricky when you're first doing this. So now let's go through and we'll do this same idea from before. So I'm just focusing on this. I'm really not worried about what's going on in the parentheses for a moment. So 4 goes into 4 1 time. So let's talk about what does this actually look like then. So the only thing I'm worried about then is what are we actually putting in front of the parentheses. So I take the 1 times the 3. That's just 3, and then I've still got the parentheses. So the parentheses will stay intact as you go through this process. So moving on, I've got this 4 times the 1/2, so 2 goes into 4 2 times. So 2 goes into 4 2 times. And then I've got this 2 times the 1, so that's just going to be 2. So I put a 2 on the outside. I didn't even care about what was happening inside the parentheses. And then finally, with this last one, so 4 goes into 4 1 time. So I take the 1 times the 5, that's just going to equal 5. But look at what I've got now. I've got this problem, which I'd much rather do than the original problem, and now I solve as usual. So I can distribute, so this will become 9 plus 6x minus 10 plus 6x. Notice this is negative going into here, and then this all equals 5. And then I can just keep going with this. So 9 minus 10 is -1. 6 plus 6 is 12x. 6x plus 6x. And then this equals 5. So now I can add the 1 to each side. So I get 12x equals 6. And then I can divide both sides by 12. 6 over 12 will simplify to 1/2. So there you go. So this is kind of the idea behind this. So I think I said I was going to do 2 more of these, but I think in the interest of time, I'll just show you one. I have example videos where I break all of this down and I show even more. So if you want to see more examples like this, no worries, I've got you covered. So here's just one more example. So let's go through, if you want to do this one alongside me. So first things first, find the LCD and then set up the multiplication and then hit play when you're ready. So in this case, my LCD is 6. So if I set this up, so I've got this, and then 6 times the 1/3, 2x minus 5, and then this 6 times the 1/3, 4 plus 2x. Now, if you over multiplied, one thing that I find really handy if you're struggling to figure this out is to look at the original problem. And again, it's all about where are the plus or minus signs or the equal sign. So here is a term, or here's one part, here's the second part, here's the third part. So if you're struggling to figure out how many times to multiply, before you multiply, figure out how many parts of the problem you've actually got to do this to. Okay, so from here, I would recommend pausing the video, making your cancellations, and then hitting play when you're ready. So 2 goes into 6 3 times. So this little guy here, this is going to be 3 times x plus 2. And then 3 goes into 6 2 times. So 3 goes into 6 2 times. So this is going to leave me with 2 times 2x minus 5. And then for this last one, 3 goes into 6 2 times. So this will leave me with 2 in front of the parentheses. Okay, and so now I can go ahead and distribute. So this will give me 3x plus 6 plus 4x minus 10. And this will be 8 plus 4x. So I can collect my like terms to get 7x minus 4 equals 8 plus 4x. And then let's see, I like subtracting the x's off first. If you do the numbers first, that's okay. So this will give me 3x minus 4 equals 8. So let's see, I need to add the 4 to each side. So I get 3x equals 12. Divide each side by 3 to get x equals 4. Okay, so I have more example problems. I don't want to make this video too long, and it's already getting too long. So I'm going to leave it there, but if you want to see more example problems, you can check out my other videos. So otherwise, that's it for this one, guys. Thanks for watching. You got questions? Feel free to leave me a comment, and I'll read them over. Otherwise, I'll see you guys next time.